swing amplification, and the Gaia phase spirals. We explore the interplay between in-plane and vertical dynamics in stellar disks within the framework of the shearing box approximation. Julian and Toomer used the shearing sheet to show that leading density waves are amplified as they swing into a trailing ones. We extend their formalism into the dimension perpendicular to the disk and obtain explicit solutions for the response of a disk to an impulsive external excitation. An excitation that is symmetric about the midplane produces a density-breathing wave as well as two armed phase spirals in the vertical phase space plane. On the other hand, an excitation that is antisymmetric about the midplane leads to a bending wave and single-armed phase spirals. In either case, self-gravity plays a crucial role in driving the evolution of the disturbance and determining the amplitude and pitch angle of the ensuing spirals. We also show that when the disk is excited by a co-rotating cloud, it develops stationary phase spirals in the wake of the cloud. The results call into question simple kinematic arguments that have been used to determine the age of the phase spirals seen in the Gaia survey. Next article. Discovery of a quiescent galaxy at C73. Local galaxies are known to broadly follow a bimodal distribution, actively star-forming and quiescent system. Why, when, and how such bimodality was established, and whether it has been associated with different processes at different cosmic epochs, is still a key open question in extragalactic astrophysics. Directly observing early quiescent galaxies in the primordial universe is therefore of utmost importance to constraining models of galaxy formation and transformation. Early quiescent galaxies have been identified out to redshift Z less than 5, and these are all found to be massive. Here we report the discovery of a quiescent galaxy at C equal to 7.3, when the universe was only 700 m old, about 5% of its current age. The JWST NIRSPEC spectrum of this galaxy from our JADES program exhibits a complete absence of nebular emission lines, while the Bomber break and Lie alpha drop are unambiguously detected. We infer that this galaxy experienced a short and intense burst of star formation followed by rapid quenching, about 10 to 20 m before the epoch of observation. Particularly interesting is that the mass of this quiescent galaxy is only 4 to 6/108 solar mass. This mass range is sensitive to various feedback mechanisms that can result in temporary or permanent quiescence. Therefore, this galaxy represents a unique opportunity to learn more about galaxy formation and transformation in the early universe. Next article. Probing the rapid formation of black holes and their galaxy hosts in QSOS. Using the modeling code XSigil, we reproduce the SES of 1/359 SDSS QSOS within the redshift range 0 less than Z less than 4, for which we have Nuremberg fluxes with the highest quality and spectral data characterizing their SMBHS. Consistent with the rapid formation of the host galaxies, the star formation histories have small e folding, at most 750 ms using an SFH function for spiral or 1000 ms using Wildfire Athletic. Above CSIM 1.6, the two solutions are degenerate, the SEDS being dominated by the AGN continuum and high star formation rates, typical of starburst galaxies, while at lower redshifts the starburst nature of the host, independent from its morphology, is better reproduced by in-spiral SFH. In general, the SFR increases with the redshift, the mass of the bulge, the AGN luminosity and Eddington ratio, suggesting there is no evidence of a GN quenching of star formation. Comparing the specific bar with specific SFR, all the QSOS at any redshift trace a linear sequence below the Eddington luminosity, in parallel and above the one-to-one relation, implying that QSOS are in a special phase of evolution during which the growth in mass of their SMBH is more rapid than the growth in mass of their galaxy hosts. This particular phase is consistent with a scenario where the galaxy hosts of QSOS in the past grew in mass more rapidly than their SMBHs, suggesting that a high star formation efficiency during their formation was responsible in limiting their masses. Next article. A variant on the mechanism for bar instabilities. The problem of how disk galaxies avoid forming bars remains unsolved. Many galaxy models having reasonable properties continue to manifest vigorous instabilities that rapidly form Stroll bars, and no widely accepted idea has yet been advanced to account for why this does not generally happen in most disk galaxies. The unstable mode that is responsible for bar formation is believed to be a standing wave in a cavity that reflects off the disk center and the corotation radius, with amplification at corotation. Here we use simulations to address one further idea that may perhaps inhibit the feedback loop and therefore contribute to stability, which is to make the disk center dynamically hot and or to taper away mass from the inner disk, which could be masked by a bulge. Unfortunately, we find that neither strategy makes much difference to the global stability of the disk in the models we have tried. We did, however, discover one interesting wrinkle to the cavity mode in strongly cut-out disks. The wave may reflect from a radius in the disk that is clearly outside the center, although the ingoing trailing wave still reflects into an outwardly traveling leading wave. Next article. Beyond ultra-diffuse galaxies, Roman II environmental quenching of mass size outliers among the satellites of Milky Way analogs. Recent observations have reignited interest in a population of dwarf galaxies that are large and diffuse for their mass, often called ultra-diffuse galaxies. However, the origin and evolution of these mass size outliers and the role of environment are still unclear. Using the exquisitely deep and wide hypersuprime CAM strategic survey images, we search for ultra-puffy galaxies, defined as being 1.5 sigma larger than the average size for their mass, around Milky Way-like galaxies. We present the size and radial distributions of mass size outliers and derive their quenched fraction to explore the impact of environment. Surprisingly, despite being outliers in size, the ultra-puffy galaxies have a similar quenched fraction as normal-sized satellites of Milky Way analogs in both observations and simulations, suggesting that quenching is not tied to being a mass size outlier. The quenched fraction is higher for the ultra-puffy galaxies associated with redder hosts as well as those that are closer to the host in projection. In contrast, the ultra-diffuse galaxies are overall redder and more quiescent compared with normal satellites. We show that the classic definition of ultra-diffuse galaxies is heavily weighted towards quenched galaxies and thus cannot be used for a study of quenching of mass size outliers. Next article. X3, a high-mass young stellar object close to the supermassive black hole SGRA. To date, the proposed observation of young stellar objects in the galactic center still raises the question where and how these objects could have formed due to the violent vicinity of SGR, a star. Here, we report the multi-wavelength detection of a highly dynamic USO close to SGR, a star that might be a member of the IRS-13 cluster. We observe the beforehand known coreless bow-shocked source X3 in the near and mid-infrared with Symphony, NACO, ISIP, VISIR, SHARP, and NIRCam2. In the radio domain, we use CO continuum and H30 alpha ULMA observations to identify system components at different temperatures and locations concerning the central stellar source. It is suggested that these radio sum observations in combination with the Nurbiar gamma line can be associated with a protoplanetary disk of the USO, which is consistent with manifold Visser observations that reveal complex molecules and elements such as Civ, Ni, and Arii in a dense and compact region. Based on the photometric multi-wavelength analysis, we infer the mass of 1510.5 solar mass for the USO with a related age of a few 104. Due to this age estimate and the required relaxation time scales for high-mass stars, this finding is an indication for ongoing star formation in the inner parsec. The proper motion and 3D distance imply a relation of x3 and IRS13. We argue that IRS13 may serve as a birthplace for young stars that are ejected due to the evaporation of the cluster. Next article. Deep Synoptic Array Science, a massive elliptical host among two galaxy cluster fast radio bursts. The stellar population environments associated with fast radio burst sources provide important insights for developing their progenitor theories. We expand the diversity of known FRB host environments by reporting two FRBs in massive galaxy clusters discovered by the Deep Synoptic Array during its commissioning observations. FRB 20,220,914a has been localized to a star-forming, late-type galaxy at a redshift of 0.1139 with multiple starbursts at lookback times less than 3.5 Ch in the Able 2310 galaxy cluster. Although the host galaxy of FRB 20,220,914a is similar to typical FRB hosts, the FRB 20,220,509g host stands out as a quiescent, early-type galaxy at a redshift of 0.0894 in the Able 2311 galaxy cluster. The discovery of FRBs in both late and early-type galaxies adds to the body of evidence that the FRB sources have multiple formation channels. Therefore, even though FRB hosts are typically star-forming, there must exist formation channels consistent with old stellar population in galaxies. The varied star formation histories of the two FRB hosts we report indicate a wide delay time distribution of FRB progenitors. Future work in constraining the FRB delay time distribution, using methods we develop herein, will prove crucial in determining the evolutionary histories of FRB sources. Next article. Simultaneous millimeter wave gamma ray and optical monitoring of the Blazar PKS 2326-502 during a flaring state, including millimeter wave data in multi-wavelength studies of the variability of active galactic nuclei, can provide insights into a GN physics that are not easily accessible at other wavelengths. We demonstrate in this work the potential of cosmic microwave background telescopes to provide long-term, high-cadence wave GN monitoring over large fractions of sky. We report on a pilot study using data from the SPT-PAL instrument on the South Pole Telescope, which was designed to observe the CMB at arcmute and larger angular scales. Between 2013 and 2016, SPT-PAL was used primarily to observe a single 500 to the power 2 field, covering the entire field several times per day with detectors sensitive to radiation in bands centered at 95 and 150 GHz. We use SPT 150 GHz observations to create a GN light curves, and we compare these wave light curves to those at other wavelengths, in particular gamma ray and optical. In this letter, we focus on a single source, PKS 2326-502, which has extensive daytime scale monitoring data in gamma ray, optical, and now wave between 2013 and 2016. We find pKs 2326 to 502 to be in a flaring state in the first 2 years of this monitoring, and we present a search for evidence of correlated variability between MM-wave, optical R-band, and gamma-ray observations. This palette study is paving the way for GN monitoring with current and upcoming CMB experiments such as SVT3G, Simons Observatory, and CMB-S4, including multi-wavelength studies with facilities such as VRO-LSST. Next article. The Greta-Bate gas phase reaction network: the importance of being exothermic. The gas phase reaction networks are the backbone of astrochemical models. However, due to their complexity and nonlinear impact on the astrochemical modeling, they can be the first source of error in the simulations if incorrect reactions are present. Over time, following the increasing number of species detected, astrochemists have added new reactions based on laboratory experiments and quantum mechanics computations, as well as reactions inferred by chemical intuition and similarity principle. However, sometimes no verification of their feasibility in the interstellar conditions, namely their exothermicity, was performed. In this work, we present a new gas phase reaction network, Greta-Bate, based on the KETA 2014 network and updated with several reactions, cleaned from endothermic reactions not explicitly recognized as such. To this end, we characterized all the species in the Greta-Bate network with accurate QM calculations. We found that 5% of the reactions in the original network are endothermic, although most of them are reported as baryolous. The reaction network of seed-bearing species is the most impacted by the endothermicity cleaning process. We also produced a cleaned reduced network, Greta-Bate Red, to be used to simulate astrochemical situations where only C, O, N, and S-bearing species with less than 6 atoms are needed. Finally, the new Greta-Bate network, its reduced version, as well as the database with all the molecular properties, are made publicly available. The species properties database can be used in the future to test the feasibility of possibly new reactions. Next article. Membership analysis and 3D kinematics of the star-forming complex around Trumpler 37 using Gaia-Doctor 3. Identifying and characterizing young populations of star-forming regions is crucial to unravel their properties. In this regard, Gaia-Doctor 3 data and machine learning tools are very useful for studying large star-forming complexes. In this work, we analyze the 7.1 degree 2 area of one of our galaxy's dominant feedback-driven star-forming complexes, i.e. the region around Trumpler 37. Using the Gaussian mixture and random forest classifier methods, we identify 1,243 high probable members in the complex, of which 60% are new members and are complete down to the mass limit of 0.10.2 solar mass. The spatial distribution of the stars reveals multiple clusters towards the complex, where the central cluster around the massive star HD 206,267 reveals 2 subclusters. Of the 1,243 stars, 152 have radial velocity, with a mean value of 16.41, 0.72 kms. We investigate stars' internal and relative movement within the central cluster. The kinematic analysis shows that the cluster S expansion is relatively slow compared to the whole complex. This slow expansion is possibly due to newly formed young stars within the cluster. We discuss these results in the context of hierarchical collapse and feedback-induced collapse mode of star formation in the complex. Next article. The Lyman alpha reference sample Roman 14 Lyman alpha imaging of 45 low-redshift star-forming galaxies and inferences on global emission. We present light alpha imaging of 45 low-redshift star-forming galaxies observed with the Hubble Space Telescope. The galaxies have been selected to have moderate to high star formation rates using far ultraviolet luminosity and high equivalent width criteria, but no constraints on light alpha luminosity. We employ a pixel stellar continuum fitting code to obtain accurate continuum subtracted light alpha, H alpha and H beta maps. We find that light alpha is less concentrated than FOV and optical line emission in almost all galaxies with significant light alpha emission. We present global measurements of light alpha and other quantities measured in apertures designed to capture all of the light alpha emission. We then show how the escape fraction of light alpha relates to a number of other measured quantities. We find that the escape fraction is strongly anti-correlated with nebular and stellar extinction, weakly anti-correlated with stellar mass, but no conclusive evidence for correlations with other quantities. We show that light alpha escape fractions are inconsistent with common dust extinction laws and discuss how a combination of radiative transfer effects and clumpy dust models can help resolve the discrepancies. We present a star formation rate calibration based on light alpha luminosity, where the equivalent width of light alpha is used to correct for non-unity escape fraction, and show that this relation provides a reasonably accurate SFR estimate. We also show stacked growth curves of light alpha for the galaxies that can be used to find aperture loss fractions at a given physical radius. Next article. Quiescent and active galactic nuclei as factories of merging compact objects in the era of gravitational wave astronomy. Galactic nuclei harboring a central supermassive black hole, possibly surrounded by a dense nuclear cluster, represent extreme environments which house a complex interplay of many physical processes that uniquely affect stellar formation, evolution, and dynamics. The discovery of gravitational waves emitted by merging black holes and neutron stars funneled a huge amount of work focused on understanding how compact object binaries can pair up and merge together. Here, we review from a theoretical standpoint how different mechanisms concur to the formation, evolution, and merger of COBs around quiescent SMBHS and active galactic nuclei, summarizing the main predictions for current and future detections and outlining the possible features that can clearly mark a galactic nuclei origin. Next article. Young radio sources expanding in gas-rich ism using cold molecular gas to trace their impact. We present the results from the study of the resolved distribution of cold molecular gas around 8 young, peaked-spectrum radio galaxies. This has allowed us to trace the interplay between the radio jets and the surrounding medium. For 3 of these sources we present new CO observations obtained with NOMA. In 2 targets, we also detected CN lines, both in emission and absorption. Combining the new observations with already published data, we discuss the main results obtained. Although we found that a large fraction of the cold molecular gas is distributed in disk-like rotating structures, in most of the sources high turbulence and deviations from purely quiescent gas were observed in the region co-spatial with the radio continuum emission. This suggests the presence of an interaction between radio plasma and cold molecular gas. We found that newly born and young radio jets, even those with low power i.e. P-jet less than 10 to the power 45 erg-s, can drive massive outflows of cold molecular gas. The outflows are, however, limited to the sub-KPC regions and likely short-lived. On larger scales, We observed cases where the molecular gas appears to avoid the radial lobes and, instead, racks around them. The results suggest the presence of an evolutionary sequence consistent with simulations, where the type of impact of the radioplasmid changes as the jet expands, going from a direct jet-cloud interaction on sub-kpc scales to a gentler pushing aside of the gas, increasing its turbulence and likely limiting its cooling. This effect can be mediated by the cocoon of shocked gas inflated by the jet-cloud interactions. Building larger samples of young and evolved radio sources for observation at a similar depth and spatial resolution to test this scenario is now needed and may be possible thanks to more data becoming available in the growing public archives. Next article. H2O megamaser emission in NGC 4258 indicative of a periodic disk instability. H2O megamaser emission may arise from thin gas disks surrounding the massive nuclei of galaxies such as NGC 4258, but the physical conditions responsible for the amplified emission are unclear. A detailed view of these regions is possible using the very high angular resolution afforded by space very long baseline interferometry. Here we report SBLBI experiments conducted using the orbiting radioastron observatory that have resulted in detections of the H2O 22 GHz emission in NGC 4258 with Earth space baselines of 1.3, 9.5 and 19.5 Earth diameters. Observations at the highest angular resolution of 11 and 23 μs show distinct and regularly spaced regions within the rotating disk at an orbital radius of about 0.126 tc. These observations at 3 subsequent epochs also indicate a time evolution of the emission features, with a sudden rise in amplitude followed by a slow decay. The formation of the emission regions, their regular spacing, and their time-dependent behavior appear consistent with the occurrence of a periodic magneto-rotational instability in the disk. This type of shear-driven instability within the differentially rotating disk has been suggested to be the mechanism governing the radial momentum transfer and viscosity within a mass-accreting disk. The connection of the H2O megamaser activity with the magneto-rotational instability activity would make it an indicator of the mass accretion rate in the nuclear disk of the host galaxy. Next article. Formal stability analysis for the recent gamma-5 power law spherical accretion solution. Accretion problems in astrophysics. Next article. First detection of co-emission from Cepheid variable stars. We present IRAM 30M telescope observations of the CO and CO emission lines in a sample of 8 Cepheid variable stars. The CO line is detected in 4 of the 8 targets at a signal-to-noise of greater than 3.5, confirming the presence of CO in Cepheid atmospheres. 2 sources show strong absorption in both CO lines. This is likely related to contamination by cold molecular gas clouds along or close to the line of sight. The remaining 2 targets showed no strong features related to either CO line. These detections represent the first direct evidence for the presence of CO in Cepheid atmospheres, providing strong evidence for the mechanism proposed to explain the observed mid-infrared color variation seen in Cepheids. Further, these detections support the proposed use of mid-air color as a robust photometric metallicity indicator for Cepheids, potentially leading to the elimination of metallicity systematics from the H0 air budget. We discuss the future studies needed in this area and how our observations can be used to inform optimal observing strategies for large-scale dedicated studies. Next article. Robust field-level likelihood-free inference with galaxies. We train graph neural networks to perform field-level likelihood-free inference using galaxy catalogs from state-of-the-art hydrodynamic simulations of the CAMELS project. Our models are rotationally, translationally, and permutation invariant and have no scale cutoff. By training on galaxy catalogs that only contain the 3D positions and radial velocities of approximately 1,000 galaxies in tiny volumes of 3, our models achieve a precision of approximately 12% when inferring the value of omega. To test the robustness of our models, we evaluated their performance on galaxy catalogs from thousands of hydrodynamic simulations, each with different efficiencies of supernova and a GN feedback, run with 5 different codes and subgrid models, including Illustris, Simba, Astrid, Magneticum, and Swift Eagle. Our results demonstrate that our models are robust to astrophysics, subgrid physics, and subhalo galaxy finder changes. Furthermore, we test our models on 1,024 simulations that cover a vast region in parameter space variations in 5 cosmological and 23 astrophysical parameters, finding that the model extrapolates really well. Including both positions and velocities are key to building robust models, and our results indicate that our networks have likely learned an underlying physical relation that does not depend on galaxy formation and is valid on scales larger than at least 10 H1 kpc. Next article. Implementing RFI mitigation in radio science. This paper presents an overview of methods for mitigating radio frequency interference in radio science data. The primary purpose of mitigation is to assist observatories to take useful data outside frequency bands allocated to the science services. Mitigation should not be needed within passive bands. Mitigation methods may be introduced at a variety of points within the data acquisition system in order to lessen the RFI intensity and to limit the damage it does. These methods range from proactive methods to change the local RFI environment by means of regulatory manners, to pre- and post-detection methods, to various pre-processing methods, and to methods applied at or post-processing. Next article. Low-frequency radio recombination lines away from the intergalactic plane. Diffuse radio recombination lines in the galaxy are possible foregrounds for redshifted 21 cm experiments. We use edges drift scans centered at 26.7 declination to characterize diffuse RRLS across the southern sky. We find RRLS averaged over the large antenna beam reach minimum amplitudes between right ascensions 2 to 6 H. In this region, the C-alpha absorption amplitude is 3311 Mk averaged over 50 to 87 MHz and increases strongly as frequency decreases. C-beta and H-alpha lines are consistent with node detection with amplitudes of 1314 and 1210 Nk, respectively. For 108 to 124.5 MHz, we find no evidence for hydrogen or carbon lines at the noise level of 3.4 Nk. Conservatively assuming observed lines come broadly from the diffuse interstellar medium, as opposed to a few specific regions, these amplitudes provide upper limits on the intrinsic diffuse lines. The observations support expectations that galactic RRLS can be neglected as significant foregrounds for a large region of sky until redshifted 21 cm experiments, particularly those targeting cosmic dawn, move beyond the detection phase. For C-alpha, we find a best fit departure coefficient product, N-beta, that varies smoothly as a function of frequency between 0.79 less than N-beta less than 4.5 along the intergalactic plane and between 0 less than N-beta less than 2.3 away from the intergalactic plane, yields better agreement between model and data than assuming local thermodynamic equilibrium conditions. Next article. Chronometric theories of modified Newtonian dynamics. Next article. Exact solutions for black holes with a smooth quantum core. A class of exact solutions are presented for the interior of black holes of solar mass and beyond. In a core enclosed by the inner horizon, the binding energy released by dissolution of the pre-collapse nuclei is stored in electrostatic and zero-point energy. Gravitational collapse is prevented by their negative pressures. In the mantle, the region between the inner and event horizons, there is a standard vacuum. Accounting for the rest masses of the up and down quarks and electrons leads to corrections at the percent level. Spherically symmetric fluctuations have a spectrum without unstable modes. A surface layer with a charge current can be present on the outer side of the inner horizon. A layer of opposite charges on the event horizon can make an extremely charged black hole neutral. Merging of an extremal black hole with another extremal one or with a neutron star may produce electromagnetic fireworks. Next article. Next article. Next article. The JCMT Nearby Galaxies Legacy Survey SCUBA-2 observations of nearby galaxies. We present 850 new observations of a sample of 8 nearby spiral galaxies made using the SCUBA-2 camera on the James Clerk Maxwell Telescope as part of the JCMT Nearby Galaxies Legacy Survey. We corrected our data for the presence of the 12 code J equal to 32 line in the SCUBA-2 850 new bandwidth using NGLS HARC data, finding a typical 12 code contribution of 20%. We measured dust column densities, temperatures, and opacity indices by fitting spectral energy distributions constructed from SCUBA-2 and archival Herschel observations, and used archival Galex and Spitzer data to make maps of surface density of star formation. Typically, comparing SCUBA-2 derived H2 surface densities to sigmosphere gives shallow star formation law indices within galaxies, with SCUBA-2 derived values typically being sublinear and Herschel derived values typically being broadly linear. This difference is likely due to the effects of atmospheric filtering on the SCUBA-2 data. Comparing the mean values of sigma-2 and sigmosphere of the galaxies in our sample returns a steeper star formation law index, broadly consistent with both the Kennicutt-Schmidt value of 1.4 and linearity. Our results show that a SCUBA-2 detection is a good predictor of star formation. We suggest that Herschel emission traces gas in regions which will form stars on timescales 5/100 mm, comparable to the star formation timescale traced by Galex and Spitzer data, while SCUBA-2 preferentially traces the densest gas within these regions, which likely forms stars on shorter timescales. Next article. Young stellar distance indicators and the extragalactic distance scale. The extragalactic distance scale is perhaps the most important application of stellar distance indicators. Among these, classical Cepheids are high-accuracy standard candles that support a 1.4% measurement of Hubble's constant, H0. The accuracy of Cepheid distances is thus directly relevant for understanding the implications of the Hubble tension. The greater than 5 sigma discord among direct, late universe H0 measurements and H0 values inferred from the early universe observations assuming Lambdictum cosmology. This invited review aims to provide an accessible overview of the state-of-the-art distance ladder that has established the Hubble tension, with a focus on Cepheids, their absolute calibration using trigonometric parallaxes from the S emission Gaia, and other Cepheid-related systematics. New observational facilities such as JWST and upcoming large surveys will provide exciting avenues to further improve distance estimates based on Cepheids.